The concept and original design of steel balls telling time by running on tracks comes from USA in 1970s. Clocks were handmade from wood in a family-run workshop under a name Idle Time. There is still active Idle Time website with an essay on history of their business. Due to increasing number of orders, Idle Time gave license to Arrow Handicraft Corporation to produce electric ball clocks on a large scale. Arrow transformed the design by making it smaller, use plastic instead of wood, and selling as a self-assembly snap-fit kit. I think the self-assembly idea was really good. Owners had a chance to enjoy achievement of building the clock themselves, but also they could better understand how it all worked. It went into production in USA in 1978. The arm moving 3/8 of an inch bearing balls was attached to AC mains high voltage motor rotating continuously at the speed of 1 rotation per minute. There were two sizes of the clock, more popular, smaller electric ball clock and bigger deluxe electric tennis ball clock. Although name is misleading here, it was closer in size to the original wooden clock, but definitely nothing to do with the size of real tennis balls. The clock soon went on sale across the whole world. In Europe it was sold by Mattel, a Barbie toy company. Also can be found under German brand Dexim. The name was Roll-O-Clock in Europe. Over the years, tracks, balls and moving parts remained the same. However, it was sold after different names and box designs. It is important to know that first generation Arrow Mattel, powered by AC motor, needs not only correct voltage, but also correct mains frequency to be accurate. US clocks run on 60 Hz, European clocks on 50 Hz. Basically, this clocks sync rotation speed with mains AC current frequency. So simple US to European voltage transformers do not warrant accuracy. US in Europe runs slow, European in US runs fast. The second generation. I'm guessing that second generation was introduced around early 1990s, after Arrow ceased production. I do not know much about the American toy company selling them called Can You Imagine the Future of Fun? The second generation are known as time machine kinetic display clocks and were made in China. They use the same plastic parts and are the same size as Arrow design. The motor is however different. It is much safer, low voltage 6 volts DC motor and more accurate by introducing quartz electronic timing circuit. Clock can be used anywhere in the world by simply selecting appropriate DC power supply. It is even possible to run it off popular 5-volt USB with custom-made cable. Arm was not rotating continuously and slowly, but rather picking up the ball in a one fast rotation lasting around 10 seconds and then waiting still until next minute. There was also seconds indicator on top of the motor assembly. Clock could have been powered by 4 C-size batteries located in the compartment at the rear of the base, or separate DC power supply rated at 100 milliamps, 6 volts, with the unusual negative central pin, positive outside ring. Another change was to assemble the clock in the factory. Self-assembly fan was taken away. It was not a flat pack anymore. On the good side, a variety of fluorescent glow-in-the-dark blue, green and orange colors were introduced. I do not know how long they were produced. I suspect time machines were still available in the shops in the first years of 2000s. Some of the recent boxes have QR codes on them suggesting smartphone and internet era. What goes wrong in ball clocks? Plastic is of good old quality. Rails, chimneys, balance platforms, gates usually have minimal wear from use and are not easy to break or deform. Steel balls can go missing, but are cheap and easy to replace. Size is 9.5 mm, 3/8 of an inch. The AC motor in the first generation is the weakest link. Original was made by Intermatic. Cogs were steel apart from two plastic ones. The smaller cog, sitting directly on the rotor spindle, literally falls apart into small pieces with age and makes the motor to fail. I guess the reason for using plastic cog there was proximity of magnetic field and hence avoidance of interference from more durable but ferromagnetic metal. I could not find a suitable, reasonably priced replacement. No, I'm not paying $30 plus shipment for such a trivial thing. Cog specs are 5 mm diameter, 12 teeth, rotating freely on 1.8 mm spindle, in case you know where to get one for a couple of bucks. Alternative is to find another working Intermatic motor. They were quite popular in electromechanical timers, Sankyo alarm clocks and other toys. But it will fail again, almost for sure. Or be creative and get a different AC or DC motor or whatever else that rotates the arm in the clockwise direction at the speed of 1 RPM. I'm not able to comment on the longevity of the second generation DC motors. They should be easy and cheap to replace. The common problem with them is corrosion in the battery compartment. There are some comments about poor quality of PCB soldering at the Chinese factory and aging capacitors requiring renewal. Remember the unusual plug polarity. Another issue for all clocks is acrylic clear dust cover, also serving as a noise blocker. It scratches really easily, it is prone to cracks and damage and yellows with age. How much is it worth in 2024? The most recent time machines were sold in shops for between $30 to $50 when new, before discontinued about 20 years ago. There are some dreamer sellers online listing all ordinary, not working Arrow or time machine ball clocks wanting hundreds of $. The reality is that new custom handmade to order wooden clock possibly can be had for $300. Here is what I would consider a fair value for them after some market research. Avoid category. Clocks with incomplete or broken essential plastic parts, missing tracks, platforms, arms. They are worth nothing and can only be of interest to those looking for particular single parts. Many thousands of ball clocks were sold over a quarter of century, and there is still plenty of complete sets offered frequently for sale. For repair category. No box, no manual, visible signs of use, not running, but present faulty motor and all plastic parts present and in good condition. Balls may be missing. It's worth around $10 to $15. Increase to $20 with good acrylic dust cover and complete set of balls. Working category. As previous one, but good running motor and fully functional arm picking up and dropping balls. Depending on cosmetic condition, $35 to $50. Box and manual add another $10 to $20 depending on their condition. Boxed new old stock is $100. The most valuable for me would be first generation, early 1980s European version of Arrow Mattel Dexim, unassembled, boxed, complete kit with parts in sealed bags. My estimation is $150 to $175. No offers, please. I'm happy with the one I have already.